Hello, my name is Nick Simons. I'm a program manager on the Fluid Framework team, and today we're going to talk about the Fluid Framework.
And I'm Dan Wallin on the Cloud Advocates team. I work with Microsoft 365 and Azure, and I'm excited to be here to share more about Fluid with you.
So today we're going to spend a little bit of time talking about what Fluid is and why you would use it. Then we're going to actually get into a little bit of how it works at a high level so you can get a sense of how data flows through the system. And finally, we're going to do some demos and we're going to actually walk you through the code and show you how to build a Fluid application. So the first question we have to answer is, what is the Fluid Framework? The Fluid Framework is a set of client TypeScript libraries designed to sync state across multiple clients. So anytime that you need to sync state across clients, the Fluid Framework is going to be a great fit. There is a Fluid server component, but you do not need to write any code that runs on that server. It's a general purpose server. All of the developer code is client side.
So the next question you might ask yourself is, so when would I use the Fluid Framework? And the answer there is really anytime you need to sync data between multiple clients. And there's a lot of different scenarios where this can come into play. One of those might be real-time editing of text, such as in a rich text box, where Nicole gets on and Nick gets on and I get on, and we need to collaborate on that, but it's just in one text area. That actually gets a little tricky because you can't just necessarily go with always take the last one, because that could wipe out everything else people have done. So the Fluid Framework will do a lot of this heavy lifting for you, and there's quite a bit of fun algorithms behind the scenes to make this happen. We'll talk about some of that coming up. Another scenario would be presence. You might want to not only capture the user names and information about users and show that, but even tracking things like their mouse cursor position. Now you need something that's very low latency to do that accurately, and Fluid can provide that. Inking would be another option. Maybe it's as simple as an app that is a family map of where they want to go on vacation, but right now one kid's off at college and maybe mom wants to highlight different cities they want to visit with that son or daughter they have. Well, inking is also part of something called a DDS that we're going to cover momentarily here that would allow you to sync that type of data, which could be pretty substantial, across one to many of clients out there. And then another example would be games. Now, obviously games, you really need low latency. And if you wanted to sync state across games, you could certainly do that using the Fluid Framework. Now, are these the only options? No. We could go on and on and on, but alas, Nick, we only have limited time, right? So we're going to focus on a few of these scenarios and walk you through how that works as we move along. But before we do that, let's get into the next question here you might have.
So looking at all those examples that we just discussed, a sort of question we often hear is, okay, those are interesting problems, but they've largely already been solved. So why would I use the Fluid Framework instead of some other technology? And ultimately, the answer is because solving those problems is really hard. And the Fluid Framework is designed to allow you to solve that class of problem of syncing data across clients in a much simpler way, where you can really focus on writing software as if you were just writing code working against local data. And the Fluid Framework does the bulk of the heavy lifting to make sure that all of your data is in sync across all of your clients. All right, so let's take a look at the Fluid Framework in action. So we're going to look at a couple of demos. The first one is on fluidframework.com, and you can follow along just by going to fluidframework.com and going to our playground. And in the playground, we have a number of demos that you can try out, but the one that I'm going to show is a real-time text editor that one of our developers created using the Draft.js open source project. This actually required relatively few lines of code, and you can see some of that code here on the page, and this is all available in our open source library. But right now, you have essentially two, these are fake browser apps, but this is actually using the Fluid framework to communicate, and there is a version of the server running in the browser. And you can see that as I type on the left, you can see the text on the right, and I can go over here and I can do some formatting, and you can see it's all propagated over here, and it lets me do insertions, and it all works just really, really well. And we can do this at an enormous scale. We would have no problem handling actually hundreds of users. The really only limitation being the JavaScript code in the client.
That'd be fun with 100 of us typing in there, huh, Nick? I'd
I think it might be a little hard to follow what's going on, but
yes.
the framework can actually handle that.
I was going to say, but we could do it, right? We could do it.
We could actually do it. It wouldn't get bogged down on the server at all. The server could completely handle it.
What's real quick? Walk us through what's a little bit tricky about this, though, because if you have that fifth or whatever it is right there, and if I were to change that, but then in the meantime you changed it, that gets really tricky to manage, right, and synchronize.
No, it does. It's tricky for the framework. It isn't tricky for me writing the code.
Yep.
So we use a distributed data structure called a shared string, and the shared string has the properties necessary to handle all the merges and keep track of where all the users are. So there is some code that needs to be written to make some decisions about changes, but relatively little. This represents maybe 100 lines of code.
Yeah, and I should have clarified. What I meant by that is if I write it on my own from scratch, that would be pretty involved.
Oh, that would be that. Well, I worked on a project to do that with Microsoft Word, and that represented quite a lot of effort. So the next demo that I want to show is actually a demo that I showed in a previous talk that I did for the Build conference that we also did online, and you can go look on YouTube. But the difference between that version is that version, I didn't show nearly as much of the code, and we're going to go into much more detail today. And also, this is actually running on the internet. So what we did is we actually stood up our reference implementation of the Fluid service, and that's Routerlicious. That's running in, it's a Docker container that we're running in Azure. And we also took the demo code from our open source repo, and we created an instance of that as a static web app, and that's what we're actually looking at right here. And that allowed us to create this collaborative experience, and sort of basically now Dan is also connected to the service, and you can see that when he adds a sticky note, it shows up in both of these clients. And if I add a sticky note, and I'm just using auto text, and we can just keep on going and adding sticky notes, and pretty quickly, and I'm just going back and forth. It's instantaneous. I'm seeing Dan's changes immediately from this browser on the left to the browser on the right. It's all going over the internet. So these are actually, this is real performance. There's no local server in this case, and I can vote on the ideas that Dan thinks is interesting, and he can vote on the ideas that he thinks is interesting. And obviously, this is just a demo application, but just to give you some idea of how long it took to create this, this represents about a day's work to sort of from scratch. And that includes building the UI in React and working out which DDSs to use and writing it. And we're going to show you the code, just in a little bit.
So before we jump into the big picture of how Fluid works and some of the different building blocks that you would use, let's talk about a few definitions you're going to see coming up. Now, one of those that you heard us use a little bit earlier is distributed data structure, or DDS. I mentioned that if you want to send game data, ink data, text data, key value paired data, you need a way to do that and then automatically sync across all these distributed clients that we have. So we can do that through the magic of something called a DDS. These are primitives that are built into the Fluid runtime that allow us to set and get data. But behind the scenes, Nick will walk us through in just a little bit here about how they will take care of syncing all this across the different clients. Now, another term you're going to hear us use is op. As the user types into a rich text box, or a game activity occurs, or you just want to send a key and a value, that's going to trigger an op to be sent up to a Fluid server. And this server is going to be responsible for stamping these ops and making sure that they're in the proper order. Now, what's kind of really nice about this, and the reason we can get low latency, is the server is a pretty minimal overhead. The clients are actually going to have the merging functionality to make sure that eventually these ops are consistent across all of the clients that we have. We call this eventual consistency. And that's another important thing that we're going to walk you through here in just a bit. And then finally, we're going to see something called a data object. And as it says here, this is really a way to encapsulate one or more DDSs. And DDSs, again, are how we can set and get collaborative data, send that distributed data. And we need a way to organize those into what I like to think of as a bucket. And we're going to call that a data object. And it's going to provide some other functionality that we're going to talk through as well. So let's take a look at this from a high level, and then Nick's going to walk you through a little more details. So first off, when we as a user go to a website, we need to collaborate, but as a developer, what's involved to make that collaboration possible? And the answer is really the three things we just talked about. We have DDSs, data objects, and then we're going to have ops. Now, in this first diagram, you can see that we have a data object that encapsulates our DDSs. And then we're going to need to sync that up with a view. Now, there's different ways we can do that, but for one of the more simple scenarios, we could actually subscribe to an event emitter, just something that could send an event inside of the data object, and then the view can then be notified, hey, this change, this change, this change, and whether it's React or Angular or Vue, you could then sync that up in the DOM, the HTML UI. Now, of course, this is collaborative, so we do need to send ops that a user types or interacts through maybe a mouse, whatever it may be, up to a Fluid service. There is some storage involved, but then as multiple users join, we need the same type of process to occur. So here would be an example of we have another user joins and we get the ops, and then we could add a third user into the mix here. And they would be doing these DDS get and set operations that send the ops up to the Fluid service. And then that kind of magically distributes these, stamps them with an order, and eventually all of our different clients would then be in sync. Now, of course, we're only showing 3 here. This could scale out to many, many more if we needed to. Now, these are the things we're going to focus on in just a moment when we get into the demo. But before we do that, let me switch over to Nick, and he's going to provide some more specifics about how all this works.
So when you first load a Fluid application, there's a small piece of code that we call the loader, and its responsibility is to take the URL that loaded the application, and it uses that URL to reach out to a Fluid service to fetch information that tells it what code to load into the application. Now, this code is not stored in the storage. In this case, the code was loaded as part of the application, and it was then instantiated from a factory. But the loader could also go to a CDN to fetch the component code and load it here. And so you can see that it's loaded something called a container, which is effectively the wrapper for the Fluid application. And you can see the data object that we talked about before, and there's a couple of views. Now, the way that the data actually passes back and forth between the data object and the Fluid service is, as Dan already mentioned, is basically through DDSs. That ultimately the runtime is paying attention to these DDSs, and anytime a DDS changes, the runtime will notice and create an op, send that through the driver that is the translation layer between the client and the Fluid service. And that, there are different drivers for different Fluid services, but ultimately that is provided as part of the framework. And then the runtime receives ops, and the runtime's job is to make sure that it keeps all of the DDSs in sync. And so, as we've already mentioned, the role of the service here is very simple. All it does is it takes all those incoming ops, it orders those operations, and then it broadcasts them to all the clients with that sequence, so that the runtime is able to produce the same exact DDSs in every single client. And the Fluid service also stores the data to the storage layer as well. So as you saw in that other diagram, we use WebSockets to communicate between the client and the Fluid service. And this leads to the sort of question we commonly get, which is the Fluid framework different from other WebSockets technologies like SignalR and Socket.io? And the answer is yes. It is very different because it is actually doing basically significantly more work than those other frameworks. So SignalR, Socket.io, they do a lot of work to make sure that it's really easy to send messages from clients to servers and have those messages be synchronized across all of the clients that are using SignalR, for example. But Fluid actually goes one level abstraction higher, and the Fluid framework takes responsibility for making sure that actual data structures are kept in sync. So the developer doesn't think about messages at all. The developer just works against those data structures. And while with simple data structures, you might imagine that would be fairly simple to manage using something like SignalR, when you get into much more complex data structures, like a shared string used for real-time text editing, that actually becomes extremely complicated. And all of that is abstracted away, or the bulk of it is abstracted away from the developer, so the developer can focus on building the actual customer experience instead of worrying about the plumbing of maintaining state across all of those clients.
So Nick just walked us through then things like the runtime and the service that we have and other aspects of this that tie it all together. But as a developer, what is it you need to actually build? What type of code would you write? And the answer there is really what we covered earlier. You're going to worry about the data objects, which are kind of the buckets for the DDSs. And then, of course, you have to worry about the view because we need to get that data into the screen somehow. But as I've already mentioned, the view could be anything. It could be Angular, React, Svelte, Vue. Pick your favorite one that you like to work with, and that would be fair game to use because this is just JavaScript. Now, you could think of the data objects and the DDSs as really being your data model. And if you're not familiar with the model concept, really all we're saying is it's kind of the source of truth of the data on the client side, except in this case, the data could be distributed, of course. That's the whole purpose of this, real-time collaboration. So what we're going to do coming up here is walk you through a demonstration of what would the data objects and the DDSs look like. And that demo that we showed earlier would actually walk you through Brainstorm. And we're going to walk through some DDSs and data objects that you would use there. Earlier, you saw the Brainstorm demo that Nick and I collaborated on. So what we're going to do is dive into the code. And you can go to this GitHub link you see here if you'd like to grab this repository. So let me go ahead and with that, open it up in VS Code here. All right, so the first thing we're going to do is jump into the data object side of things. But before I do that, we have two branches here if you go to the repo that you can check out. So the main branch, if I switch to that one, would let me run it locally. Now, it's not going to use a server that stood up out there on the internet like Nick and I did in the demo, but it would let you run this locally and try it out, and you can find instructions in the README. Now, what we've done is created a second branch called Ignite Dev, which I'm already on. You'll see down here in the left-hand corner. And this has some kind of blanks that we're going to fill in and explain what's going on sort of step by step with our data objects and our DDSs and our views. Now, what I'm going to do is walk you through using some snippets that we have for you. So we have some diagrams that you can look at later if you're interested to highlight what we're focused on. So we'll start with the data object, then we're going to move to some DDSs and the code that's involved from there, and then we'll switch to the views as mentioned as we get toward the end of this. So the first thing, Nick, we covered was as a developer, the two critical things you'll worry about is data objects and views. And so you'll see I've opened up a file here that imports some different symbols, we would call them, from the Fluid framework. So these are up on npm.js. And then if I scroll on down, you'll notice that we have this class here that extends data object. Now, this is the one provided by the Fluid framework, and it's, again, the bucket that's going to allow us to add multiple DDSs for our notes, our users, our votes, all that fun stuff. So if I come on down, you'll notice that we kind of have an area here for defining properties. And let me put these in, and I'm going to have Nick walk us through kind of what is a shared map, Nick? Because we talked about it briefly, but we didn't go into much detail there.
So a shared map is simply a series of key value pairs. And it's exactly the same as, or almost exactly the same as, a JavaScript map that you're probably used to using if you're coding using JavaScript. The big difference being that because this is a DDS, the Fluid runtime will keep the shared map in sync across all of the clients.
So basically, as you clicked on a note and I clicked on a note, we were setting the value of the DDS, and then the runtime and all that Fluid server stuff we talked about kicked in behind the scenes?
Exactly. Basically, you just make changes to the shared map, and the distributed data structure means that it's in sync. Something else to point out here about these particular ones is you can see there's a notes map, and that's going to contain all of the note objects, the sticky notes that we showed in the brainstorm demo. Below that, there's a votes map. And the reason why we're separating votes from notes is to avoid any data conflicts. So you could imagine that votes would just be a property on a sticky note, and that you would just increment the votes on that sticky note. But because these are shared maps, they use a last writer wins conflict resolution model. And so if you just used a property, you might end up stamping on someone else's vote. And voting is extremely important. We want every vote to be counted. So in this case, we have a separate shared map where the votes are all individually managed as different rows in the shared map, and then there's no risk of any conflict.
Exactly. So in other words, we're kind of separating the functionality by notes and users and votes so that we don't conflict with each other and, I don't know, step on toes, I guess you could say.
Yeah, you just need to give that a little bit of thought when you're thinking about how to use DDSs, because there is the possibility of conflict.
So now we've seen some basic shared map properties. Let's jump on down to what happens when the first person actually hooks up to all of this. Well, that's going to trigger a lifecycle function called initializing first time that you'll see here. And we're going to come back to that in a moment because it's going to be really important for actually getting these shared maps going. Because up to this point, we just have some properties defined, but we don't really have anything hooked up to them. Now, to make this a little easier to create these shared maps, we're going to come on down and add a little helper function that I'll walk you through called create shared map. Now, you'll see that it takes an ID as a string, and we're going to use that as the key here for a set, which we'll talk more about momentarily. But notice first, we're going to call this shared map.create. So up top, we've imported shared map. We're going to call create, and then our data object provides this runtime property that Nick showed earlier in the diagram. So we're going to hook that up to the shared map because that ultimately is what distributes the ops. Now from there, we're going to take the ID that we pass in, which you'll see in a moment as well, and we're going to pass the shared map's handle. So basically a reference to the shared map. And we're going to set that on something called the root. Now, do you want to walk us through what the root is real quick, Nick?
Absolutely. So when we extended the data object, one of the things that we get out of doing that is a root DDS. And the root DDS is already connected to the Fluid runtime. And that DDS is effectively what makes it easy for us to add more DDSs that we want to keep in sync. So what we're doing here is we have a root DDS. It's actually something very much like a shared map, but it's called a shared directory. It's because it has some hierarchy. And then any DDSs we add to the root now will be kept in sync by the Fluid runtime.
Awesome. So coming on back up now to the initializing first time, let's put both these on the screen. We can come on in And we can actually call this helper to create our shared map for notes, votes, and users. Now, at this point, I want to emphasize we've only set the shared map on the root, as Nick just talked about, but we haven't hooked it up to the properties yet, but we're almost there. We'll get to that coming up next. So far, we've defined our properties. We've actually created them and added them to the root shared directory that Nick just talked us through. Now, the last kind of magic is now we need to go get those from the root and associate them to the properties. So let me go ahead and do that next. And we'll plop in some code here. Now, notice we have another function called hasInitialized. And hasInitialized is for if Nick triggered all this. So he called the first one up here, called initializing first time. And let's say I and Nicole and other people join later. Well, that would call hasInitialized. And you would need to also get the shared maps hooked up to the runtime. Now, what we can do there, though, is say, go to our root and go get one called notes or votes or users, and that would get us to the handle. Then the .get here at the end would get us to the actual object, the DDS itself, that we would use to get and set data collaboratively. Now, we're going to go ahead and assign that over to our properties. Those are the same ones we defined up top, and now we're kind of in business. Now, the next step of this is we probably need a way to get data, know when data changes. We need to set data because obviously when Nick clicks on a note to add it, that's going to set to the DDS. So let's keep on moving down here.
Although, well, there is one thing you might be wondering, which is why we're creating these local references at all. You can operate directly on the data structures that are in the root. But as you can see from the code here, that requires that you make async calls. If you create these local references, you can work in just with synchronous code. That makes the calling patterns much, much simpler. And so that's why we're creating these local references. But you can, if you want, work directly on the DDSs that are in the root.
That's a good point, because this is really just simplifying the other alternative, right? Because otherwise it'd always be an async call.
It would always be an async call. The only DDS you can call not async is the root.
Exactly. Excellent. Well, moving on down, what we're going to do now is we need to know if Nick were to add a new sticky note or Nick votes or someone else votes, how do we know about that? And the answer there is we're going to have a little helper again for create event listeners so that when notes map changes or votes map changes, we can be notified of that. So let me go ahead and put this one in. And you'll notice we're simply going to pass in this case, notes map. That comes in as a shared map. And then we're going to subscribe. We're going to say, hey, anytime a value changes, then please notify me about that change so that I could do something with the view. Because if a new sticky note comes in, we need to be able to get to that text and then update whatever view we have, React, Angular, Vue.js, whatever it may be. Now, in this case, Nick, we're being like super basic, right? We're just saying, hey, any change that happens, emit an event out that the view could listen to, but we could definitely get more granular, right?
Yeah, we could be much more granular. We could be more specific, not only about which parts of the data model have changed, but we could actually get into the specifics of what has changed. But it turns out in this particular example, the only thing that we actually need to know is that anything has changed in our data model, and then the view just is able to reflect that change, and we don't really need to worry about what specifically has changed at all. That's kind of the cool thing about React.
And we'll be actually looking at the change event on how we subscribe to that or get to it in just a little bit as well. Now, the final thing we want to point out for you is we mentioned that this is a map, a shared map. So think of a JavaScript map where you can get and set values and do things like that. You know, how do we actually set data, for example? Like if Nick clicks on a note, how do we get that note transmitted? So let's move on down to that. And you'll notice we have a little create note here. And all we're doing is saying, hey, if we do have some text, let's go ahead and create an object literal. Now, this needs to be something that's serializable because ultimately it'll become JSON data. And I'm making an ID, I'm assigning the text. And in this case, we're actually tracking the user because obviously we can have multiple users in a collaborative scenario. Now, this is how easy it is to transmit it, though, to everyone that's hooked up to this. We simply treat it as go to the shared map in this case called notes map, set based on the key, which in this case is the node ID, obviously. And then we give it that object we want to serialize. Now that will become an op that would be transmitted to the Fluid service. It'll stamp the order, and then all the others would get that, and eventually they will be consistent and match up. Anything else you want to add on that piece there, Nick? Because that's pretty cool, I think.
It is, but I think you covered it really well.
Awesome. All right, well, you're probably wondering, if we go back up, we emitted the change, and how does the data object and this change, how does that actually hook up into the view? In this case, we have a React app, and we have a little start function that kicks all this Fluid loading off. And let me let Nick walk us through the first part of this, and then I'll describe how we get the data object into the view. So take it away, Nick.
So if you think back to the diagram that I showed earlier, I talked about the Fluid loader, and its job is to take the URL and hit the Fluid service and find out which code to load. And that's what these two lines of code are effectively doing. The first one is essentially getting that container that I talked about, which effectively is the wrapper for the application. And then it's using that container to get the default object, which is the data object that ultimately is going to instantiate the DDSs that we just talked about. And really that's what so that all of that diagram is covered by these two lines of code.
So it's really simplified the runtime and connecting to the Fluid service and all that fun stuff. Yeah.
Yeah.
So the next magic is, we mentioned earlier that the data object really is a model. It has the data. And we need to subscribe to the change event and interact with that and things. So the way we're going to do that is we have a custom component here. We're going to use the standard React DOM.render to render that to kick things off. And we're going to pass this as a prop called model. Of course, you can call it whatever you want, but we called it model. And then whatever this component renders, that would go out to this content div that's in the application. So if we jump on over to our component here, you'll see that if I scroll on up to the top of it, it's just a really standard React function that takes in some props. Now notice as I highlight the props, you can see where they're being used here to get to the model. And these are some of the functions that you would find in the data object. We didn't cover all these, but they're in there. Now, this generate state is responsible then for, hey, as users are added or as notes are being added, this is going to create an object that we can then render in the DOM, the document object model. So if we move on down a little bit to our use effect, we're using React hooks here. We can say, hey, anytime the model has a change event that fires. Now remember, if we go back to our data object, that was our, hey, anytime a shared map changes, the value changes, we want to fire this event. Well, that gets us back to here. That calls on change, which really just sets the state that I showed right up top here. Now, this data, as well as some other data, is then used to render the pad that you see, the board that you see that has all the notes with the buttons and all that type of stuff. So for instance, when they click on create note, we simply call that function we just talked about, right, Nick, that's back here in the main. And that makes it really easy now to have, I would argue, a very clean separation where your model is responsible for all the syncing stuff. We can subscribe to events, we can call into it, but in this case, React is responsible for all the rendering aspect.
Yeah, there's a very clean division between the model and the view in this example, and that's something which we recommend when building Fluid solutions.
So that's a look at the data objects, the DDSs, the views. Now from here, we could actually run it locally. We could go in and do an npm start. You could check out the README if you're interested. But I hope that walks you through. And Nick, thanks for your input there on all the ins and outs of how this all works.
So in September, we open sourced the Fluid framework, and we've seen an enormous amount of interest, lots of views, a few PRs, and we're really excited to have people participate. Our goal is to look at all of that feedback and look at all those contributions and work with the community to get to the point where the Fluid framework is ready to build production solutions. We don't have a a precise timeline for when we're going to be there, but it's a very high priority and we're working very hard to get to that point. Also, we have a hosted fluid service in the works, and that fluid service is coming in the future. We do not have a precise timeline, but our goal is that when we are able to stand that up, you won't have to worry about deploying your own fluid service. You will be able to use a general service that Microsoft will make available.
So thanks for joining us. For more information about the Fluid Framework, we definitely hope you'll check out the repository, visit fluidframework.com, go through some of those demos and the docs. And Nick, it's been great talking through this with you.
Thank you so much for your time. And we're really excited to have you take a look and contribute to the Fluid Framework.